Good afternoon, everyone. Thank you for your interest in joining the webinar. In today's session, we are going to explore the latest IS1893-2025 code, a brief discussion, and then we are also interested in presenting you a plugin program that we have developed to help our users as an interim arrangement till the fully implemented ETABS is available. Yes. The 1893-2025 has several parts of it. Part 1 covers general provisions and applicable for all the buildings. And then part 5 specific for buildings systems. So from the forward of part 1, we recognize these information such as the structure, how this code has been organized, the part 1 general provisions, and then other parts dealing with various other structural types. So in our case, we are taking up the buildings part 5. So the usage of part 1 must be read in conjunction with the specific part relevant to this structure type, which is building system for our case. And then parallel standards are also applicable, such as IS13920 and 13935 for assessment and retrofits. So the major changes from the previous version of the code will be the new hazard map. A huge amount of work has been gone through this, a revised earthquake zone map based on probabilistic earthquake hazard assessment, accounting faults, tectonics, and ground motion attenuations. They have developed involving some 1.5 million earthquake records. This has been generated, and I think this is also available as a database for those who are interested in the BAS website. Then the design spectra, which we'll be using, that is now extended up to 10 seconds, and ground motions. Design horizontal acceleration coefficients will be based on return periods. And suites of ground motions also available for the response history analysis, or also called time history analysis, for both near fault and far fault. And geotechnical aspects, new method to account for soil flexibility, and revised method for estimating the liquefaction potential. And architectural or non-structural elements protection is also covered in a special section. These are the major things, the part 1. And if we go to the building part 5, again, there are specific changes. Now we have the masonry, concrete, and steel sections dealing with several aspects of the design. And codes highlighted in red will be withdrawn, as all the aspects relevant will be covered in this code. Now we will go through these code provisions based on part 5, but whenever the general provision needs to be accessed, that will be covered automatically. The section starts at number 5, and here we have the guidelines even before the design, the site selection, the ground motions, and the earthquake effects on buildings. So even before the design, you have all these checks in place so that, for example, site selection, the liquefaction check has to be done and large side effects are checked, and then ground motions. It should be noted that the design spectrum does not account for near fault earthquakes. So it will be based on far fault. So if you want to consider near fault for those sites where near fault earthquake are possible, then you will have to consider it through a time history analysis where near fault earthquakes are also available through the database. So that's how it is. This is an important thing to be remembered based on the site selection. And other update would be on the design forces and the design of members from zone 3 and above. Ductile provisions are applied, right? So inelastic behavior and flow response spectrum in case of secondary systems, there are equipment resting on these floors. So this flow response spectrum can be obtained from a time history analysis. So that is general performance expectations, section 5.6, which discusses the philosophy in detail, but this should be the main clause that one should start reading the code to understand various changes and the expectations or the performances when the structure is being designed using this code. So this code specifies the minimum requirements for normal and important structures. And then for critical and special structures, may require rigorous site-specific investigations for more accurate hazard assessments, right? Now this is based on categories of structure or classification: normal, important, critical, and special. This is also a new thing. And the damage expectation is that sustain structural damage, but should not collapse. And advanced protection can also be used, such as base isolation, dampers, or energy dissipating devices in general is intended to improve performance and alleviate damage, not just reduce cost. The other benefits are also there. Then we have the damage control clause. So we need to identify the mode of failure during the analysis stage, collapse mechanism that it should follow, and the damage locations where it should occur. And that should be a global ductile response. And structural integrity, that means the primarily LFRS must maintain integrity and robustness under strong shaking. That means the load path clearly identifiable. Continuous load paths to the foundation should be established. Redundancy, that is to redistribute in case of the members fail, there should be redistribution of loads happening to other members. That should also be identified. Overstrength, elements likely to yield must have sufficient plastic deformation capacity to redistribute load. Foundations and connections must withstand extreme forces transmitted by the yielding of structure without significant damage. And the desirable collapse mechanism, which we were discussing, the concept is that a state where select elements behave ductile while others remain within design limits. So an absorption should be a large portion of earthquake energy should absorb through this ductile behavior. So identification, the mechanism should be identified at design stage considering the overstrength of elements. Now, that is through the key elements. So key elements, the members whose loss result in disproportionate damage or collapse. So the name itself says that the key elements going to absorb the energy a lot. So identification, once you have identified through the iterations of the analysis, you will also have to do additional checks by removing that member, assuming that it has failed, and perform a nonlinear analysis of the residual check for large deformations. And the design requirement for such elements are also mentioned here. This is mandatory for critical and special structures. That's why I wanted to point this out and reading this 5.6. And then recommended for important structures and in general applicable for all structural categories. Then estimation of design earthquake hazard. So the ground shaking for both horizontal and vertical are considered. And then design earthquake hazard zones is the new one, revised from the previous one, and you can see the update. And we have the design earthquake peak ground acceleration and elastic normalized acceleration velocity displacement response spectra. We also have site-specific so mandatory for requirement of site-specific earthquake hazard. We will discuss this, but we will not be using it in this presentation. But enough guidelines now available for the site-specific response spectra usage. Procedure is given to you now. Now from sections 14 and 16, we have, I think 13, 14, and 16, we have the structural system clearly descriptive for you to select based on the zone and the building category, right? The left one is for the concrete and the right one is for the steel. You can see. So I think the short forms of this are pretty obvious. SMRF is special moment resting frame, special structural wall. FS means flat slab. DS means dual system, satisfying the dual system requirements. And then for the analysis, we have the effective section properties clearly given for various members. Including axial, shear, and moment of area, the moment of inertia. Right. Now we have the I value, importance factor, based on 4 categories. It's normal, important, critical, and special. So in this code, it is given as 1, but you can also use a higher value if so desired by the designer and the party. Elastic force reduction factor, R, the name has changed from response reduction factor. This is also listed in a descriptive manner to select easily in table number 7. And then the zone factor is based on the return periods for the limit state method, which is highlighted in red boxes. You can select the zone factor directly from the table. And then the calculation of the base forces for horizontal and then vertical. The formulas are given. and there is a minimum base force, and the distribution still follows the quadratic distribution as earlier. The response spectra and site class. So the response spectra, to select, we also need to know the site class. This will be based on the shear wave velocity that needs to be calculated, and the correct site class needs to be identified. A, B, C, D, and E is for site-specific response spectra. The normalized design horizontal elastics spectra is given, one for above ground and for below ground. So for the above ground, we have these two. This is the values are listed with the formulas. We can use that and identify the normalized design elastic acceleration. Okay. So that's just to remind you once again, the design spectrum, you can see the provisions of this standard do not account for near fault ground motions in the design spectrum. So in case of the site is at a near fault or subject to near fault ground motions, then we will have to use a response history analysis or the time history analysis, where you will be considering near fault ground motions as an input. Another important update on the torsion. So we have the clear distinction between the analysis types and what are the design eccentricities for each of them. It's been listed. Another new introduction is the torsion flexibility, psi, and the formula is given based on the ratios of dimensions and the ratio of torsional mode time period to the translation mode time period, and then that is listed. The ratios are listed to select or see what are the options you have. If psi is less than 0.4, you can perform the analysis with the design eccentricity specified here. If it is greater than 0.4, revise the structural configuration. And this table reveals on a significant ratio, that is, you can see this tau value, which is the tau theta, that is torsional mode to the translation mode ratio. When it is greater than 0.9, then torsion eccentricity, this is not applicable, not permitted, basically. Right. So this is going to play a key role in our analysis, where our torsional mode time periods will be pretty close to translational X and Y time periods. So the separation has to be huge to achieve this ratio, and then you can do the analysis as per this design eccentricity requirement. This is going to be significant. And lastly, for the analysis, the model is geometry must accurately represent the whole structure's configuration and irregularities. Material properties must reflect the expected response. The mechanical properties and mass and stiffness must capture 3D distribution, and stiffness estimates must include flexural and shear deformations consistent with the actual behavior. So boundary conditions support condition must reflect actual site condition. Artificial hinges are prohibited in monolithic concrete structures. The hinges for concrete members, that is not allowed, which cannot be achieved. And the soil flexibility, when considered, recurrent static use flexible soil springs, and dynamic consider full soil structure interaction required. So when you have the soil subgrade modulus, then you have to analyze in another iteration with varying the K values to understand the earthquake hazard better. And shear deformations, the effect of shear deformations must be explicitly included in the stiffness matrix. That is already taken care by the program. And we also have the clear descriptive way of identifying the structural analysis type for the linear analysis. So equivalent static for all zones, all building category, all building configuration, regular or irregular, and time periods. Yes. And then dynamic analysis is clearly given here, response spectrum for all zones. And one you can see here is recommended for buildings with natural period more than 0.4 seconds. So the approximate natural time period formula is given. Follow that, and then if it is greater than 0.4, then both the methods are recommended. The design will have to decide on the analysis type. Then lastly, we have foundations under the miscellaneous section. When foundations are considered, ignore for footings or wraps on ground, shallow foundations, full inertia for footings, wraps on piles, then inertia above ground level when pile or well foundations. And soil flexibility need to be modeled in elevation aspect ratio. So guidelines are available, and then there are restrictions. Avoid foundations vulnerable to differential settlement in zone 3, 4, and above. And isolated RC footings without tie beams prohibited on site deep classes. So several restrictions, and can also find interconnections that are tie beams to be modeled. The footings and pile gaps. So foundation design is also becoming slightly complicated with all these checks. And then cantilever projections, vertical and horizontal. So vertical projections, anything that is projecting from the building, like water tanks, towers, basically any structure that is not part of the building lateral force resisting system, then these can be modeled as lumped mass at the roof level, and their design must using this force R times AHT value. And then for horizontal projections like balconies, etc., the design requirement must it has to be designed for the AVD TV of the building. Now we got this information from one of our users for two types of buildings. One is only frames. It is special moment resting frames of 5-story building. And the other one, the second, is special moment resting frame plus special shear wall of 14 stories. And the immediate difference, what we see is the rise in the base shear is the input. It is double because earlier that Z by 2 is now only Z, that difference is immediately, and the design of the members also affects. Right. So these are the important and major points that we want to discuss regarding the code. And for this change, specifically on the input side of the modeling, we have generated a plugin for our users, as I said at the beginning, as an interim arrangement, which will be distributed to all of you free of cost. Now let me take you to the plugin and demonstrate and discuss few things over there as well. Now we have a sample model just for the demonstration purpose, but we tried our best to give all the inputs here through that plugin. Now plugin is a piece of code that you can attach to this ETABS program. It is also possible for other CSA products. That can be attached to the tools from the menu. Under the tools, you can find add show plugins. There is a default one provided with the program. I will go for add show plugins. And this form is going to help you to browse to that file. Browse. And the file is being in this. And you will find for this plugin, we have named it as IS1893-2025 helper plugin by CSI ESPL. It's a DLL file. Select and open. You'll also see a status OK. Once you have added, you can also rename them if you want, but this is okay. We'll go with the default naming, my prefixed, and the rest of the name as a plugin name. And important to notice, the status must be showing OK to use this. And you can select this. And you can also check the info. Press OK. Now we'll find this plugin available and ready to use. Before that, let me discuss about the model. So this model, assume that is a special moment resting frame only model. And for using this plugin, we have to prepare this model for few things. One of them is the load patterns for the seismic. So what our recommendation is, because this is new, the current auto lateral loads is not going to help until the new version comes with that update. So we are going to utilize the user coefficient till then. So you can name them. For demonstration, I have used EQX 2025 and then seismic type and auto lateral load as user coefficient. I've created X and Y. And we also have other dead loads and live loads of various types present in the model. And we also have the temperature and one more load pattern for the Z direction. which cannot be applied as user coefficient, which has to be none, and user will have to handle this at this point of time. So I'm going to demonstrate only the horizontals for this. So in this user coefficient load pattern, we'll modify the lateral load, and we will leave the factors to the default values, and you set the story range, and you also specify in which direction you're applying it. So I've selected only the X direction. Since eccentricities are new, this cannot handle it. So either you can specify it as a ratio if you calculate, or use the overrides. Manually calculate and apply it for positive and negative. So that's how the use case would be for this with eccentricity options. So let us go with X. Same goes for Y. Okay. Then I will go to the tools. I will start the plugin. It's the main plugin form where we have two helpers at this stage. We have one for the design seismic hazard inputs, the load patterns and spectrum functions. Other one is to generate load combinations. To select the first one, press open. So we have on the left the input parameters we need to use. Currently it is only available for limit state method. And then you'll have to select the zone, building category, structural system, and site class, and the time period method to be used. So now the code is given as three formula. First one RCMRF, that means it is based on the first, including the SPD, that is structural plant density values. Others need not require that information. You can also specify a user value of time period in case you will have to calculate the time period in a different way. For example, this code allows you to use this up to 50 meters only. Beyond that, you will have to refer to 16700 code, and that TA has to be an user input. Right. Let me go with that formula. First one. The next input is the vertical time period. The default value is 0.4, but you can use this from your model analysis. And then structural damping ratio by default is 5% of critical damping. Any other value you can also input. That will also be considered accordingly as per the procedure given in the structural plant density for columns. Let's put 5%. Just for demonstration purpose, you can calculate and give this exactly. And shear walls, at this point of time, this is not automated. So kindly bear with us because it requires a lot of effort. These three values will be an user input. So at this point of time, in the denominator, we have the component for the shear walls. We want you to input that value manually calculated here directly. Let's say there is no shear wall in this building. I'm keeping it 0. And masonry walls, if any, that can be added as a percentage directly. I'm keeping it 0. Let us give the building dimensions. Height, this is 12 meters. Then depth in the direction of the loading, say for the X, say 18 meters. And this seismic weight is optional, informative only. You can put some value to get this design base shear. And we'll press calculate. And this will calculate, pick up the zone factor correctly, R value, I value, and approximate time period calculated using that formula given here, and the normalized pseudospectral acceleration value, and then the design acceleration and the minimum reported here. And then the final value will be used in calculation. So design base shear, I'm using unit horse, so you can see 0.04 rounded off the second digit being a design force. Similarly, for the 0.4, you can also calculate the vertical acceleration coefficient. And this program allows you to give a user input value as you need it. But let us assume the calculated values are fine, and then you want to update this in the model. So for that, we will go for third group, which is equivalent static method. So what it does is the user will have to select the load pattern we just prepared using seismic user coefficient and just simply press update load pattern. You'll get a message here, updated. Then we'll do this for Y direction. The values are different, can change. Not be changing significantly because of dimensions. And we will update QY, update load pattern. So currently the vertical acceleration coefficient is only reported, which has to be applied in a linear distribution along the height as suggested in the code. For the horizontal, it is quadratic distribution, which is taken care by the program. We do this. And for the response spectrum, you can generate the response spectrum functions. And you'll see the location where this is saved. You can also create a report if you want. For the equivalent static method, we save this also. The report saved. And then you can close this. We'll close this and we'll come back. So it should say plugin completed successfully. Now we will review the model. Load patterns, coefficients, and it has used this value 0.037 and the K value, which is 2, represents the quadratic distribution. The base shear coefficient is the key from the plugin that we got for both X and Y. All right. Now we will go ahead and define response spectrum functions. So we will add this from file option we just generated. Add new function. The values are period, this is value, acceleration. Go to the browse under the model. So these text files will be saved in the model file folder. You can see this horizontal we just generated. You can name it IS1893-2025. The spectrum is ready to use, and they'll also add for horizontal. Similarly, we can do this for vertical as well. Let me complete this by defining the load case. And you'll find this spec X and spec Y. So the initial scale factor will be G value as earlier, then scaling as required after the analysis will have to be done. Let's update this model with all the input data. Now we will also have the load combinations. Just let's clear the current ones and we'll create our own combinations using the plugin. We'll go to the tools once again. We'll use the plugin. This time we will select generate load combinations. Let's open, and we will get load cases from the model. And dead and live are gravity load case lists. So there is nothing to select here, just to show the list of cases available of various types. This involves all deads, super dead, lives, pattern live, proof live, reducible live, all of this. So you can include all of this, and then you have to set seismic cases in the respective directions. And then the omega overstrength factor to be used should also be specified here. The default value is 2, specified here. And then for the equivalent static seismic, you have select these cases, assuming that EQZ is also defined and manually the loads are also applied. I will select EQZ for demonstration. And you can also consider in spectrum cases through the checkbox, or else it will be ignored. So X, Y, and Z also can select. And then the load sets as per the code, section 8431, 32, 331, and 3. basically one direction at a time, or two mutually orthogonal planned directions, or all three directions together in two different ways. If I select the one, we'll have to select generate combos. So the table below will get populated. You can see the combinations 1.2 dead, 1.2 live, and the EL with the omega factor multiplied, and then 1.5 EL, zero point 0.9 EL. Right? One's for positive, one for negative, and then spectrum is also included. Then you can see spectrum case, one positive value is sufficient. We use two mutual directions and regenerate. This is not applied to the model yet. We have a dedicated button for that. So you can review, and as the EQX is two times, that is the omega value, and then 30% of it is applied in the Y direction. Go for three directions. So you'll see X 100%, 30% in Y, 30% in Z. And same set of repetitions and find in. Go for the last one also. This one will be slightly different. Only two directions, X and Z, Y and Z. Right. Let us go with two mutually orthogonal directions, or first one of the three directions together is full, and then we will press apply compose to the model. It will update. Now, for convenience, we also included the temperature loads in case you have. Then you can also consider them, enable them, and selecting the appropriate positive and negative cases for the temperature, and then we will regenerate, and this will do one set of positive and one set of negative for each. So that becomes 162 combinations. We can simply add to the model. We can see it has been added. Then we can close. Finally, can close this. Plugin completed successfully. And if we go to the combinations, so these cases will be available, each one of it. Right. And then this needs to be included in the design. Because these are manually created, and you can perform that design as usual. So this is the use case of the plugin we wanted to present you, and this will be released later tonight. And you can check our website for the update. Now I will stop my presentation here, and I will take some questions quickly to answer. Yes. There are queries related to the modeling, especially this oil structure interaction. We will update you on this, but program is capable of doing that. but we will let you know the exact method to be followed very soon. Yeah, there is a question on damping. Yeah, I can specify a different damping ratio uh, for the spectrum. The plugin will update that automatically. Okay, shear wave velocity that needs to be calculated or reported by the geotechnical team for you to get that value, and the formulas are given in the code to calculate and to obtain this site class. Yeah, combinations. This again needs to be combinations. I'm sorry, combinations for the projections. So these needs to be separately defined and used only for that member design, not for the main structure. So we'll have to handle it that way. You can define combinations with the required enhancement for the seismic and then use it for the design of the members for one iteration of the design and then get that value for detailing purpose. That is the only way to go about it. Yes, the vertical for the vertical acceleration, that equation R has been omitted. So it has to be full value without any reduction, elastic reduction factor. That is the current. So the comparison I already showed you just for the horizontal one, that itself can reveal it as double the value of earlier code. Yeah, the comparison of base shear from the old and new code. So it is not about load combination, it is only about the estimation of the input base shear. It is not the member design combination, the estimation of the shear earthquake force. Uh, yes, there is a query related to name change. The load pattern name is user defined. You just need to select, identify and select it properly. For demonstration purpose, I suffixed 2025 as user coefficient load pattern. Yes, the plugin will also calculate the vertical seismic force. SPD column and shear all in both direction. SPD for columns is for all the columns. SPD for shear wall is for one direction at a time. Yeah, this SPD automation was not possible because we wanted to give this plugin out as soon as possible because there were a lot of queries on the automation thing. But it is something we can also always do. That's why we gave it as a user-defined value for now. Now, in the load combinations, factor 1.5 partial safety factor for the earthquake. Now we have the omega factor coming in. and the base shear will increase with that. Yeah, the plugin does not add the basic 1.5 times of dead load combination. That is, the user will have to add. Can I modify or delete the generated load when I do not want to? Actually, the plugin is only updating the load pattern we just created for the uh, seismic user coefficient. You can always delete and modify them as you want. So the plugin does not delete anything or with an option given there. Yeah. So load combinations, you can utilize that. That's why the omega value is given as an user input. By default, it is set to 2 as per the code. You can generate it in case you don't want the omega, then put it as 1 and generate the combinations. And you can save them separately. And if you want omega as 2, then run it again. But for the previous set, you can change the name for some identification with the help of um, database editing tool, interactive, that will help you in quickly fixing those things. So that's how the omega factor needs to be handled with the current state of the plugin. It is user input. Just remember that. So you can modify it. Put it as 1, and then when it loads, it takes the default value of 2. A newer version of the ETABS is expected soon, but we don't have the exact date. But early 2026 we are expecting. Just that's the only update I have right now. Yeah, minimum base shear for taller buildings greater than 50, you can compute it using 16700 and right here you have the user input. The omega factor is given under the section 2, 3, and 4. 2 is for masonry, 3 is for concrete, and section 4 is for steel buildings. So where you can find the omega factor. TV value will be an user input. So by default, it is taken as 0.4. Most cases it would be around that. It will be flat, and then get 2.5. The plugin is applicable for buildings taller than, the range 50 meter. In that case, the time periods are not applicable. So you will have to give the time period, which is also a user input. You can enable the user input value for the time period finally calculated. Program will use that TA value, what you specify from other source, that will be used in calculating the base shear coefficient. Yeah, overstrength factor for shear walls are currently not implemented in this plugin. That needs to be uh, done external to this at this point of time. we need to define a special set of combinations. For the shear wall design with omega V factor. So I think I have covered most of the questions. Most of them are repetitive. I'm trying to summarize and answer these questions. The left side of this so the left side of this is all our user input, right? In case of your time period is different, and you want to use that time period, then you can use the user value and put it here. Then program will use it. And for that, you'll have to recalculate the values. You can see T is used and the coefficients will be based on that, right? That is the additional option given to you in such situation areas, especially when the building height is greater than 50 meters and you are referring to 16700. Right. So I hope the presentation was helpful to you. Thank you all for the joining. We'll meet you on the next one very soon. Bye.